Good morning, dear students. Today we are going to talk about general information about constructions of the buildings, the requirements to them. We'll talk about main bearing elements, non-bearing elements, so about just about primary role of the building, so why we need it, so how we construct it. The main aims and tasks of our lesson to have some idea about constructions of the building, to know and have opportunity to distinguish the bearing constructions from non-bearing constructions, vertical, to be familiar with the vertical and horizontal elements of the building, and to know some methods of design, architectural, constructional structures from the course project. So there will be 5 main parts. Today we're going to talk about the first part, building structures, modular structural grid, and the planning for the next lesson. And let's start from the first part. So the primary role of a building structure is actually to support all loads, to support all actions which are accepted by the building, which are act to the building, and transmitted. So transmitted to the constructions which are located under the building, so beneath the earth. So we know that beneath the earth located substructure of the building, so we call it like substructure, and it consists of stucco level and foundations, and then foundations itself transmitted to the ground soil. So the most important characteristics of the bearing structures are, and here we see 3 main points: strength, stability, and the cost. So the strength is the capacity of a structure to carry the loads applied to it. Stability means that structure can maintain its shape, so when loads or forces are applied. So the loads and disturbances to the structure should not produce large movements or failure. So there should be stable. Stable are also the synonym of the safety. So the building and the structures should be safety. Cost effectiveness. So cost effectiveness depends on choice made regarding how the structure will carry the loads. So the structural system used and materials chosen. So in case of residential buildings, effectiveness is very important. So residential buildings actually are not the type of the building, so where you want to do something extravagant. So residential buildings are extremely rational category of the building. So usually investors already spend more money on public buildings, because public buildings can refund, so they give money back in a short time, and this means they will prepare it to have more attractive public buildings structure in order to obtain a higher visual and spatial impact on potential user. So, however, in case of residential buildings, rationality comes in the first place. Structural system of the building. So, structural system of the building made of horizontal elements and the vertical elements. So, if we'll call separately each vertical and horizontal, what we firstly need to understand. So, vertical elements are the walls, columns, in some cases, vertical foundations, like column foundation or street foundation, for example. So horizontal elements are slabs, horizontal slab, beams connected to tops of the column, truss. Truss can span a big dimensions between the columns. So the most effective length of the span can be accepted when the span is more than 12 meters. So for example, 80, 24, 30, 36, and more. So in that case, truss is more effective. Roof and foundations. So why foundations can be vertical and horizontal elements? Because they there are various types of foundations. So we know the vertical foundation like column, strip, pile foundation, and also there are slab foundation or mat foundation, which are according to their positions horizontal elements. What about walls? Walls can be, actually we'll discuss about walls more deeply in next slides. But now, so walls can be bearing and non-bearing. They can be divided according to the materials they accepted. So the hard materials like reinforcement concrete, from the brick materials, so masonry materials from bricks, from blocks, from stones, and so on. Beams, most of all beams divide into monolithic or prefabricated construction. So in prefabricated types of the building accepted prefabricated concrete beams. In monolithic buildings accepted monolithic concrete beams. So they are also divided according to the reinforcement inside. It can be reinforced by the double armature, by triple, four, and so on, according to forces acting to that beam and the aims and the length of the beam. The slab is the horizontal element which are connect all columns between each other and create the section of the building. The slab is provide horizontal stability of the building. It can be divided into two types, monolithic or prefabricated. There are various types of prefabricated slabs. It's a flat slab, it's a hollow slab, so slab with holes inside it, and so on. So each of them actually again accept in each way. So in residential buildings in Europe, usually are used reinforced concrete structures. So on the other hand, for example, in America or Asian countries, steel and wooden structures are often being used. So why? Because there are no deficit of the wooden materials in that countries, and also popular material steel, because there are can be quickly found the steel materials, so reinforcement and other rolled sections, so welded sections and so on. Okay, let's talk about walls more deeply. So walls can be divided actually differently. They can be divided according to the bearing capacity. So bearing or non-bearing walls. So as we said before, bearing walls are usually done out of reinforced concrete, and in residential buildings, their depth, so thickness of the wall, um, uh, is ranged from 20 to 30 centimeters. So it's a not means that it can be used less or not can be used more in depth, but the approximately thickness is from 20 to 30. Non-bearing walls are usually masonry walls, I told you. They done out of light concrete or brick blocks. So, or maybe bricks or just the blocks. Yes. So their dimensions vary from 25, 20, 12 or 10 centimeters, maybe 30, 40, and so on. So the big variety of the thicknesses. That's all according to the thermotechnical calculation, according to the special requirements for that buildings and so on. According to the position, so within the building, we are divide the walls on exterior walls and interior walls. That about location of the walls. Yes. So when the wall located inside, we call it interior wall. Outside, so which means with nature, with uh, in external temperature, so we call it exterior walls. So exterior walls should be insulated in order to protect building from the thermal losses. This means that total width of exterior walls, so thickness of exterior walls is, for instance, 20 centimeters, for instance, plus 10 centimeters. So it means that it is half of the thickness of the wall. So we are gives to the thermal insulation. And for example, the finisher which are applied for external wall will be mortar. So the thickness should be about 2 centimeters. So you need to understand that all these parameters are approximately. So it's just example. So each project designed by the architects, designs, engineers has its own characteristics. So has its own requirements to the width of the wall, because each country, each city has its own external characteristics, climate characteristics. So actually in the winter it's -6 degrees. So the more cold outside, the more thickness or width of the wall should be applied, and more width of the thermal thermal isolation. Yes, so means to protect from the heat losses, actually, it should be firstly calculated enough, because we accept the thickness of the thermal insulation according to the special calculations, thermotechnical calculation. You know it actually from the architecture one. I think that you have a good experience in accepting the thicknesses and accepting of the material of the installation. Next, according to the material in residential buildings. So material, one of the important thing which are applied on the initial day design, because according to it, all structural elements should be corrected, because if we will apply heavy material for walls, of course it will increase own way of construction. It will be done more difficult calculation analysis of the main structures. So when we increase own weight, of course we need to apply more hard structures, more strong structures to be ready to carry out all the weights. Yes, do you have some questions? So if you will have actually stop me and ask it, so that it's not a problem, because it's lecture for you and for yourself. That's why you can stop me, and maybe if you don't understood something I told about, of course you can ask. I ask a question and I will immediately answer it. And so what we see, the concrete, brick, stone, and gypsum walls. So gypsum walls. Each of this material applied for each purposes. For example, gypsum walls, most of all applied inside the building. So for divide some rooms, for divide some premises into the space inside the building. Yes. So stone, nowadays stone became not so popular material, but some time before, when there was a deficit of the concrete and so on, the stone was really popular. And if we'll look at ancient times, we'll find that stone was one of the popular material, because there was absence of concrete, there was just gypsum and the cement, which was the pending material for stone cladding. That's why, but of course, the stone, one of the hardest and the more durable material which are applied for the construction. Despite the concrete constructions is also very good, but the stone is a natural material. Well, other ones is the artificial materials. That's why we can say that if the material is natural, it can be long-lasting, so long operational material. It can used by the people for a long time, so through the centuries and so on. Bricks also can be various shapes, various according to the durability, according to the size and so on, and the concrete materials. And the last one, it is according to the construction method. So construction method is the construction, when the construction is done on site, for example, it call it like custom place, so it's a monolithic construction, or the main constructions are manufactured outside, so on the special designed plants, fabrics, shops, and so on. So which of these two methods should be applied for the construction? It's the decision of applying two of these methods is applied by the engineers, by the designers. Now, why? Because it all depends on the many positions like location of the building, um, like the seismicity of the region, the height of the building, the constructional system of the building, applied type of material, and so many other positions. Only by solving all of them can be applied the method of construction. So will be um, total parts of the building cast in place monolithic, or there will be total prefabricated walls, for example. Yes, but sometimes can be find the combined method. So when the some parts of the constructions made in cast in place and the some of them are made outside, so and call it like prefabricated. Classification of the structural systems. Um, there are several types of the structural system according to the position of the vertical elements. And so according to the type and the position of the vertical elements, we can divide it into three main structural systems. Actually for residential buildings, and not only for residential, but also for administrative, for offices, public buildings. That's maybe not so matter, but if we start talking about residential, so we call it like for residential. So the first one is the system with the transversal load-bearing walls. So transversal load-bearing walls is when the wall located in the transversal direction, so in the cross-sectional direction. So the constructive grid in this case varying. So constructive grid means the dimension between the load-bearing wall system, so between each other. Um, Dimension between two main bearing walls. So constructive grid varying from 3.6 to 6 meters. So dimension between them. So, but in some exceptional cases, we can have up to 7.2 meters between bearing walls. So it all again depends on the architectural design solutions. According to the internal processes, so for what purpose we design the premises, design the rooms for residential purposes or for offices or administrative buildings and so on. In usually dimensions of the bearing wall, I told you is from 20 to 30. But 2025 is the one of the popular. The next one is the longitudinal load-bearing wall system. So the second system is one of with longitudinal bearing walls. So this distance in this case are the same as in previous system, with only difference that the system is extremely flexible. This means that housing units structured with the system cannot be changed over the time. So why it is flexible? Because you see the length of the wall is 2 times or in some cases 3 times more bigger than in the transversal system. So in transversal system, there are short walls with ordinary step located in the longitudinal direction. But in this case, we see the walls are only 3 walls in the same system, in the same building, but they are more longer. So, and the long systems create the flexible material, yes? Flexible construction. Dimension between these types of the walls are the same, ranged from the 3.6 meters to 6 meters. Actually, it can be increased according to the special requirements for that buildings. Next, next vertical type of the building is the column beams system with the axial loadings. So these systems can be called like the third system most common used for the construction. In this system, dimension of vertical elements is extremely reduced, and these vertical bearing columns are instead at the intersection points of constructive grid in order to transport loadings actual to the ground. So then these points are connected with the horizontal elements, beams, and the end of it functions as a frame. So distance between grid lines are also modular, so divided by 60 centimeters. By 60 centimeters, that's important. So this means that they are usually 3.6, 4.2, 4.8, 5.6, 6 meter, and so on. So 5.4, 5.4 and 6 meter, and so on. And the first possibility of is combination of two systems. So combination of columns and bearing walls. So columns and bearing walls, for example, in our region, in seismical region, one of the popular constructional type, because we need to create the hard building, strong building, which will provide the stability and the safety for a long time of operational time, and it can maybe the main purpose that will withstand all loads and withstand all horizontal loads, transversal loads, which can be created by the wind and by the earthquakes. That's important to understand. So the vertical elements, columns, their geometry, it can be divided according to their geometry, according to the material, and according to the construction methods. So according to their shape, they can be rectangular, square, or circular. So in residential buildings, so in order to stay rational, we usually use the square columns. According to the material, we divide it into the concrete, steel, timber columns, even sort of this type of building. In this way, we use moreover the concrete ones. According to the constructional method, they can be cast in place in actually like in the previous one was, or prefabricated. So for large structures such as towers and large scale compounds, we use prefabricated columns. while for small buildings, um, most of all are used cast in place. Foundations. Um, about foundations more deeply will be discussed about next lectures, but now there are general information about types of the foundation. So foundation are the lowest element of the building. Their role is to transmit a load bearings from the upper floors to the ground. So these elements are often referred as a substructure, I told you. Purpose is to effectively support superstructure and everything above the ground. So we have wall or strap footings, and they're usually used for residential buildings. So since distance between bearing elements is not so big, um, other type that can be used isolated footings, but they're usually used for large structural distances. So in some extremely difficult and complicated cases, we use slab foundations in order to provide stability for all building against underground water. Slabs. So in residential buildings, we use reinforced concrete slabs. They are continuous and transmitting the loads into the beams or, like you see in the picture, into the walls. So masonry walls. Most commonly, depths of the slab in residential structure varies from the 15 centimeters to 18 centimeters. In some cases, more often we can find 20 centimeters depth of slab. So beside continuous slab, we also use cantilever slab for balconies, for other cantilever structures. And the last slide for today, it is roof. So roof is the top covering of the building, include all materials and the constructions necessary to support it on the walls of the building, provide protection against the rain, snow, sunlight, extreme temperatures, and wind. So the roof is a part of the building and envelope. So the characteristics of the roof depend on the purpose of the building that it covers, available roofing materials, and the local traditions of construction is wider concept of architectural design. So a roof may also provide additional living space, for example, for roof gardens and so on. So a roof of garden conservator protects plants from the cold, wind, and rain, but admits light. So that's all for today's lecture.